with a new video. Today we will talk about the CNN network that is frequently used in the field of deep learning and that I use frequently. And it's called Mask RCNN. Okay, we will start it. Okay, first of all, I would like to tell you very briefly about the CNN network. Our network, which we call CNN, and these convolutional neural networks are in image data, and it works on image data as data. And let me tell you, generally I use it for object detection, or I usually use it to classify images. There is also a regionally based network, RCNN, Regional Convolutional Neural Networks. And this RCNN also works better than CNN because it's a regional CNN network. Now, I will describe Mask RCNN very briefly since there is a little installation video today. I want to give a little information and go to the installation immediately. Now, Mask RCNN effectively finds the object in the image. That is, the objects we want to detect. They are also present in other CNN networks as Zetra-Fast and Faster RCNN and Cascade RCNN. Blah blah, which we call region proposal networks in the backbone structure. But these proposals merge over time to form a network. And on Mask RCNN, this appears to use as the RPN, region proposal networks. There is also feature pyramid networks, and using FPN and RPN anchors, an anchor-based, accord-based algorithm, and anchors and effectively identifies potential objects. And it creates a high-quality segmentation mask for them. Now you will say how this is different from other CNN networks, especially Faster RCNN. And so Faster RCNN works really well too. There is no difference in terms of it. But Mask RCNN gives a mask, high quality segmentation mask, as well as bounding boxes and prediction scores compared to Faster RCNN. Of course, we can also do transactions with this mask. And in addition to Faster RCNN, it actually has a segmentation branch, which we call a branch segmentation. As a result of the segmentation branch, we extract the object it is and obtain the pixel mask of the object. Okay, and this also happens from segmentation types to instance segmentation. There is also instance or semantic segmentation. Let's think about in the semantic segmentation. There is a person in a picture. It paints people a pink, but or what shall we say? Let's say there is a glass or bottle. When he sees this glass, he paints this glass, for example, yellow. And this is semantic segmentation, but there is this glass, for example, a yellow glass, or besides the yellow glass, there are many glasses. Because it detects each glass as a different object, the instance segmentation paints it in different colors. Now, as we said, for bounding and bounding box regression, we have added branches in parallel to an existing branch to estimate the mask in the row as region of interest we call ROI. Unlike Faster RCNN, this is a bit important pixel alignment between network inputs and outputs, and this ROI align and ROI pooling method isn't designed. Unlike Faster RCNN, it has this difference. As an application, ResNet So residual networks was used for the backbone network in the back structure. And so I'm using ResNet 101 right now, but I also tried ResNet 50 backbones. And there are very slight differences between the layers of ResNet 50 and ResNet 101. And the layer difference consists of 50 layers and 101 layers. They did this 32. Here are different numbers, or they expanded it extensible a bit. Differently derived backbone networks, which we call ResNext, and they made it available. And as a result, in the background, this is important, MS COCO used as transfer learning. And we use ways which I will show in a moment. Okay. So our extra model doesn't have a weight training process. Let's do it like this. Actually, I want to go from RCNN's original paper. And you can see in this paper. Let's do it like this. Actually, I will also put the original paper that I've used under the video. Let's explain these RCNN papers as follows. When you look at figure 1, you can see figure 1, there is one visual. After this image, the row align. You see here pixel by pixel, which I just mentioned. So how can I explain this? And it aligns the region of interest among themselves. And the little rectangles are squares. We see here are features. Extract the features map. So let's not call it as feature maps because we accumulate feature mailer as FPN feature pyramid networks, and then is passed through collision neural networks. And these squares we can actually think of as pixels and image pixels. And what does he finally do? Take off his class box, and in addition to this, he also takes out the mask after the class box. Okay, so let's start. And I can tell you something about COCO. The weight type we use, which we call common objects in context, and produced from COCO and ImageNet data set. Okay, we could use Pascal Vogue instead of COCO. And here they explained what is COCO. After that, they put COCO's research paper, and you can see. And they included examples here in the dataset examples. And they have trained for you and said use these ways. Okay. Here it tells how many millions of images are used and how many objects there are different classes in each one. Okay, then I will use Anaconda as a platform like this. Now, okay. And then I will use Anaconda as a platform like this. We can think about Anaconda as a module that brings these platforms together. And I use Anaconda, and I recommend using it. We will call it products and individual edition download from. And since I downloaded it before, and you can see in download, and before I don't download it again, just download the version suitable for your computer. And then let's see what Anaconda is like. Okay, until it opens, let's open what we are going to clone from GitHub in a little while. And you can see I'm prepared the installation of mask RCNN repository. Okay. And now that's Anaconda. We have different menus in Anaconda Navigator, Home, Environments, Learning, and Community. And you can follow the tutorials as you wish. There are communities here, and you can enter these places and have meetings. Again, there is Stack Overflow, and the one we use the most, of course. Let's not say the framework here that we can use in home, but there are platforms: Jupyter Lab, Jupyter Notebook, Orange, and QZ, and PyCharm Professional, and of course, RStudio or Spider for our programming. You can download and use whatever you want. Then I call environments, okay, and which I created 1,000,000, and I don't operate in the base but operate in a virtual environment in order not to damage the computer base, and it's important, please. I'm going to show you that today. For example, we don't know how to create it on the terminal. How do we do it? And we'll go to the environments and we will say to create, and we will write environment name, a specific environment name, and we just need to click on the green arrow here, and we just saying create, and Python specific version you can choose and create. Okay, let's create together now in the terminal. Make directory sample, okay, cd sample, and let's create, what should we create? We should environment, and okay, conda creator and mask, okay, control the environments, mask 2, and Python 2, 6, and 12. You can choose the version. Okay, collecting package metadata. Of course, use. Oh yeah, okay. Conda activate mask 2. Okay, super. And about it, then I just showed you this. This is mask RCNN GitHub repository, and I came from here. I got it with HTTPS, and I say git clone copy its GitHub address. We are waiting for it to come into it. It's coming. Okay, git clone. We are waiting, and please be fast. My internet connection is very bad. Okay. No. I'm sorry. Okay, this is mask RCNN's GitHub code, and I came from here. I got it with HTTPS, copied, and I say, sorry. Okay, we are waiting. Git clone, copy GitHub address. We are waiting for it to come into. It is coming. Okay, my internet connection is very bad. I'm sorry. I'm so sorry. Okay, please. In the requirements.txt file, we have the libraries we want to break. I don't use GPU because of MacBook. I use TensorFlow version. And correction, TensorFlow version 1.14.0, Keras, and correction 2.0.8. Okay. And sorry, I forget it. And #5pi library 210 and 0. Okay, now pip install to R requirements txt. Okay. And besides, if you want a GPU, we just need to install the TensorFlow Tray GPU 1 and 1.15.0 and Keras 2.2.5 versions for the GPU. And it's enough to just write it's here GPU and 15 and Keras. Okay, and in addition to this 1 minute. Okay, mask RCNN release step. Okay, it's here. And mask RCNN release distribution. Good. One of the release distribution right here, and you can see mask RCNN cocoa.h5 model file, and I just said cocoa to 0. As soon as that happens, we will upload the mask RCNN cocoa h5 file. Okay, and I'm downloading. Where is the file? Okay, it's here. And I'll put it right under it too. I found it anyway. Here we download the mask RCNN cocoa h5 file, and we are waiting. Okay, I will upload them. By the way, for example, you forgot the name of the environment we work in and you don't want to open Anaconda. And with the conda info, amps command, you can see the environments you want to work with and that you have run before, and this too is finished. And if you have noticed here, there's a setup.py file, and this setup.py file actually contains all the setups, and without it is unlikely to work. So we will install the setup file, and the process is in the mrcnn folder here. Okay, Python setup file install. Yeah. Okay, these are the folders made by the creators of mask RCNN. And there are the configuration files, there is a model file, and we have folders that we call visualize for the visualization, on which we will do a lot of processing data, and we have files, and these files are very useful to us. Okay, and we installed this, we installed everything. Unfortunately, we also have PyCocoTOS. Please be carefully. Okay, and where is this? Yeah, I see. Okay, and we pull this from here too. So for Windows users, if you get a warning or error, it's because you don't have Visual Studio, or the Visual Studio C++ extension is missing. And so I can put that on the video just below, and from there you can install it without error. And I also installed this because I will use a Jupyter notebook. Sorry, pip install Jupyter notebook. Okay, soon everything will be up and running. Jupyter. Okay, super. Yeah, Mask RCNN has IPMB files that they put in their samples in the samples file, and I'm going into samples and I'm going into demo. Then let's run them in order. Okay, kernel restart and clear all outputs. Okay, we will start it. And GPU count 1 selected, GPU count 1 selected, and image per GPU 1 selected in configuration. And it's very normal to receive such warnings due to the versions. Please. Anyway, GPU, okay, image, okay, is selected, and it doesn't matter, these are the default values. And okay, let's run it, and this is actually a number of views that the GPU looks at alone, and you can choose, this is not 1 but 2, you can choose 16, it doesn't matter, they totally affect the working speed. And there is also batch size. And batch size is also getting GPU count multiply and image per GPU. You can go to the difference by changing batch size. And again in the training, after that create model will come in here, let it work on the side. Okay, create model, please. In the create model, we run the mask RCNN that they created, and we run it in inference mode because we want to see the results, and inference mode we're choosing. And we also created our config file as inference config, and you can see configuration. Okay, and our model there file already contains the model folder, something we haven't handled at the moment. And as config, we say that we are using the configurations we already use here, and let's get it working. My computer is running. We see it here, and I mentioned backbone is ResNet 101. We use ResNet 101, and if we want it, let's write it like this right now. And backbone equal to residual. Yeah. If you want it, let's write it. We can also use backbone ResNet 50, and as you can see, ResNet 50 did. and I want to use it as ResNet 101 because I found that residual networks as ResNet 101 works better. Okay, little correction. Yeah, and the algorithm we call detection of NMS, non-maximum suppression algorithm, has a threshold value, and you can see these threshold values are the values that will allow us to remove the object if the confidence values are above the threshold 0.7. And as well, of course, it is possible to get different results by trying them completely in your hands. And we are waiting for our model. Okay, it's loaded. And again, we want to inference mode and install already. Okay. And I said if they see fit, there is a reason, of course. With load Cocoa, we are working with slightly improved data by using Cocoa's weights. Now here are the class names. Here we see scissors and person, car, motorcycle or airplane. These are the class names specified. And so, of course, background of anything excluded from the object is constrained to background. And you can, of course, duplicate the class names later. And these are the classes we pulled from the Cocoa that we want to work with right now. Okay, and of course, we now run the object detection part as a result. And we are ready. And from Visualize, I already showed you where Visualize. You can also review this code from Visualize in RCNN. And let's do it back. Where is the RCNN folder? Yeah, and Visualize. You can see Visualize display instance. Yeah. And let's run it using display differences and display top masks from Visualize, and you can detect the file. And display instances takes instant data from the random choice file names, yeah, and Visualize, and we have original name and result values and region, yeah, model detection. And assigns our results to the results array 0 and infers the result from the array. And of course, you can print that too, and it doesn't matter. If you are wondering how it came out, and ROI, mask, and class ID score values will come in it. As you can see, ROI, class ID, and mask is something that is kept boolean. Yeah, okay, and print our values. Sorry. Yeah. And mask is something that is kept boolean, false or true, of course, because and it looks in the whole image. Every place where there is no mask is false, and the places where the mask is kept true, and true stays within these points we can see. And here, for example, there is more person, and that we call class name person, cycle, and chair, person, umbrella. Okay, and skateboard, you can this class name, and I can see the prediction score 96% probability that is a skateboard. And if we reduce our threshold value, our non-maximum suppression NMS threshold value up to 50%, maybe 51% chance that it looks like a skateboard or person, and 50% chance of holding objects will appear, but this is not what we want, and that's why I think 70% or 90% trash value is correct right now, in my opinion. And we already have different object detection in object images from the file, and because it is random 100% find the person, yeah, and super. Okay. And that's all I have to say for today. Thank you for listening to me. Be carefully. And thank you. Have a nice day. Goodbye.